Hi, this is Sirish from ME Design second year, class of 2022. In this video, I'm going to give you a small demo on how to use MATLAB for regression modeling. First, we open up MATLAB. And we set the specificate the folder to the folder in which we want to work with. So, for me, all my data uh, modeling data is in this MATLAB demo folder, which is placed on desktop. In this, I have my training data.xlsx and test data.xlsx. So I want to create a MATLAB file in this. So, so now I've changed the current working directory to MATLAB demo. So now we have to go to apps. While installing, when the tool asks you what all toolboxes you need to install, we are interested in regression learner. So this comes under machine learning and deep learning kit. If we tick mark that when installing MATLAB, we would be getting this regression learner. So this regression learner is available in all new versions of MATLAB. I'm not sure of what versions, but I think any version above 2015 should have regression learner. So this is part of statistics and machine learning toolbox. So I select this regression learner. Now you can see that this regression learner has opened up. So now what you have to do is go to new session and from file. We can either start by doing it from workspace if we have all the data in the MATLAB uh, files. I mean like the script file if there are if there is if the if it is available as in the workspace as some matrix or anything. Otherwise you can just go with new session open from file. Directly we can open it from the file. So here I have to specify my training data. So here I'll select this training underscore data and I'll open this. Now you can click import selection here. So here you can see that data set variable is training data which has 12 columns and 2048 rows and the response is ion. So this is our target Y and the predictors for this are 11 predictors which are TSOI, NS, ND, NCH and so on till WFGD. So these are our predictors. And now I would like to perform cross validation. So the model will get trained by cross validating it. So five folds of cross validation. What cross validation does is it will divide the data set into five parts. So the entire training data set, four parts will be used for training it and the fifth part will be used for testing. Now and now what it will do, it will consider another one part to be the testing data and the remaining four parts as a training data and it will train again. So that is what is cross validation. You can learn more about it in here and you can press start session. So this will train the model. But now for training it, we have to select one machine learning algorithm as well. So that is here. Here now it has trained. Now here you have a variety of machine learning algorithms. So here you have simple linear regression models. Fine, this is regression trees, more like that, like decision trees. Then we have support vector machines and Gaussian process regression models, ensemble of trees and neural networks. So we have many different algorithms. So based on our requirement, we could select either one of these, or you can train all of these also. So I'm currently trying to go with fine trees. It's more like a, random forest algorithm because it's based on regression tree. So I'll select this fine tree itself and I'll click train. So the model will get trained now. Here you can see that it is training and it will provide you with all the training results. So RMSE of validation, R squared error training, all those things it will give you. Now, so here the predicted that you see here is that within the training data it is showing, since you had performed cross validation, now it will show how the training model is and the predicted model is for within the training data itself. Now we want to introduce new test data to test it. So you can, in this, now that we've trained, it will show the RMSE validation like this. So this is like the training error. And here you can check the, all these are important when we insert the test data. So we'll go to test data and we'll import the test data file also from the file. Now here one thing we have to notice here is that while we are selecting training data and test data, the column names should be same in both. Otherwise there will be a mismatch. So for example, like if I show you the files, if this is the test data.xlsx and this is training data.xlsx. The names of the columns here: TSOI, NS, ND, NCH, IGS, LGS, LGD. It should be the exact same here for the test data as well. There should not be any underscore or any other kind of discrepancy between the two. Otherwise, the machine learning, there will be an error with the MATLAB while selecting the test data. So we can just minimize this. So now here in regression learner test data, I'm importing the file. And I'll import the selection. Now see that this ion is logged off here. It is automatically, it will compare with the training data and it will take this as the response. So the rest of them are the predictors. So here it's the test data and I'll import this. Now here it is, test data is imported. Now you can click test all. Now here you can see that the test data also has been, test results are also here. So the test R squared error and mean square error, all of these have been recorded here. Now what you can do is you can select for test data, you can select the test predicted and actual plot. So this is your true response and the predicted response. So true response is like the TCAD value using which we have generated the training data, and predicted response is the output of the predicted model. So here, since we had used fine tree learning algorithms, so TCAD value is already the value that is there here, this ion value, and this is the predicted response, and this is the 45-degree line. You can see that it is a pretty good model because most of the points are lying around the 45-degree line, and this is our these are some outliers with which we can remove using principal component analysis. So we can like export this model also, so that we can export this model or export this graph. We can write generate function here, so that this function now becomes a as a function in the code, so that explicitly we can give a new data and it will give you the predicted output. This is like a generate function. Or you can just export this model to the MATLAB workspace and we can work with this. So now that we have obtained this figure here, we can do many different uh, customizations to this graph. That is one advantage of MATLAB. That is, we can darken this particular lines or increase the font size, so it will be more readable for publishing papers. In papers we can customize this graph and you can use it. So that you can do using uh, here the property, I think the property inspector. So here if you can see, there will be, here you can see that the font here is Helvetica. You can change it to say Times New Roman, and you can bold it, and you can also increase the size to say, oh, this is too large. So 25 should do, or even 20 should do fine. So here you can see that the font has increased, and now you can also increase the axis. So these observation points also you can increase the point size. So here the line width is 0.5, you can make it as 1. So I have to open this. You can change the color of the points also. Okay, here the marker size is 18. You can make it 25. So you can get bigger markers now. 36. You can see you can get bigger, and the styling and color also. So based on this, you can like have different customizations. We can explore more using this property inspector. We can even increase the size of these axes here. We can darken it, bolden it, and do other customizations. So this is the advantage of MATLAB. So using this, we can also export this particular graph into a JPG or a TIFF format. So like for example, we can save this as a, here I'll give graph one, and we can check there are different formats. You can use this JPEG file, or you can save it as a MATLAB figure format only .fig, so that you can further customize it in the future. We can just open up this file and we can, so it will open up this particular window and we can customize this in the future also. So you can just like save it as a JPEG here. So now if you check the MATLAB demo, you can find that this graph one is there. So this has been exported here. Now we can use it wherever we want. So that's about it with the MATLAB regression learner. So thank you. Have a great day.